Hello and welcome back to another How to Math. Today we'll be proving trigonometric equations using trig identities. So these are all the trig identities that we'll be using today, and essentially we're just equating left side to right side. That is what we're going to prove, so we'll get right into it. First example, secant x minus tangent x times sine x is equal to 1 over secant x. So whenever we're trying to prove a trigonometric equation, we tend to try to make the more complicated side equal to the simpler side. So we'll go with the left side. So we have secant x, so that is actually, as you can see with the reciprocal identities, we have secant x, which is equal to 1 over cosine x, minus tangent x is actually equal to sine x over cosine x, and then times another sine x. And then, since they have the same denominator, we can actually make this 1 minus sine squared x over cosine x. 1 minus sine squared x is actually equal to cosine squared x. So you can make this cosine squared x over cosine x. So this is the Pythagorean identity. So sine squared theta plus cosine squared theta equals 1, or 1 minus sine squared theta equals cosine squared theta. So when we do this, we can cancel out, and yeah, so we have equal to, and then we end up having cosine x, which is actually equal to the right side already, but they wrote it in this way, in which it's actually just 1 over cosine x, so which is equal to 1 over secant x, which equals the right side. Therefore, this trigonometric equation has been proven. So that's just one example. So we used Pythagorean identities, we used reciprocal identities, and yeah, just to prove this. Now we can move on to another. I'll just erase this real quick and we can move on to the next example. So the next example will be a little bit trickier, but I'm sure we can do this. We just take it one step at a time. So the next example is secant theta times sine theta over tangent theta plus cotangent theta is equal to sine squared theta. So we'll choose the left side because it's more complicated. So left side, we can just label as left side. So first, I feel we could simplify the denominator into one fraction. So secant theta sine theta over, we can actually rewrite the cotangent theta as 1 over tangent theta. So let me make this into one fraction. Tangent theta plus 1 over tangent theta, that would be tangent squared theta plus 1 over tangent theta. Let's see here. We can actually make tangent squared theta plus 1. We can use the Pythagorean thing, so it'll be equal to 6 secant squared theta, excuse me. So it would be secant theta sine theta over secant squared theta over tan theta. So now this is actually equal to, let's see, that'll be, actually move this down, so it'll be sine theta times tangent theta divided by, actually, yeah, we can, so we can actually times secant theta, this bottom part would be secant squared theta, you can remove the squared, cancel that out, so this would end up being sine theta tangent theta over secant theta. Oops. Secant theta. Let's see, when we look at this. What could we do in order to make it equal to sine squared theta? Well, we could make tangent into sine theta over cosine theta, so sine squared theta over cosine theta. You actually make this times 1, or so times cosine theta actually, because 1, so sine theta times tangent theta over 1 over cosine theta is equal to sine squared theta over cosine squared theta over cosine theta times cosine theta, so we can cancel with the cosine thetas, equals sine squared theta, which equals the right side. So I know that thing was a bit confusing. I can actually just write it out for you guys. So from here, what I did in my head, which I should have shown in my work, is sine theta times sine theta over cosine theta divided by 1 over cosine theta. So then we just group these together, so it'll be sine squared theta over cosine theta. And when we divide by a fraction, you can actually flip it and multiply. That's why it's times cosine theta, because we flip the denominator and we make it back to over here, which we cancel out, and then we get sine squared theta equals right side. Okay, we'll go on to another example. Just gotta clear the board. If only there was a faster way to do this. If there is, please let me know in the comments. Almost done. Just hang tight. Okay, now the next example that we'll be going over, we have secant squared theta. Oops, it's lagging a bit. Secant squared theta over secant squared theta minus 1 is equal to cosecant squared theta. Now when we look at this, what could we possibly do? So we can, so of course we do the left side, so left side. We can make the denominator tangent squared theta using the Pythagorean identity of tangent squared theta plus 1 is equal to secant squared theta. So this would become secant squared theta over tangent squared theta. And then we could have, let's see. Okay, well, we can move all of this down. So it'll be 1 over cosine squared theta tangent squared theta, which you can actually convert into sine squared theta over cosine squared theta. You can cancel these out, which equals 1 over sine squared theta, which is equal to, using the reciprocal identity, equal to cosecant squared theta, which equals the right side. This was a fairly easy example. Now we can move on to a slightly more tricky one. I'm sure we can do this one. Okay, just erase. Alright, last example. We can do this. Okay. So 1 minus tangent squared x over 1 plus tangent squared x is equal to 1 minus 2 sine squared x. So of course we choose the harder side, which is the left side in this case. So we have 1 minus tan squared x. There's no trig identity for that, but there is for 1 plus tangent squared x, which is equal to secant squared x. So 1 minus tangent squared x over secant squared x. We can actually split this off into two fractions, so we can make 1 over secant squared x minus tangent squared x over secant squared x. We can make the left side, so that'll be 1 over cosine squared x, which is equal to cosine squared x. And then we have minus, we could have, so tangent squared over 1 over cosine squared x. That'll equal 2 cosine squared x. Make this sine squared x over cosine squared x. Cancel these out. It becomes cosine squared x minus sine squared x. Now using the cosine double angle formula, cosine squared x minus sine squared x is equal to 1 minus 2 sine squared x. So 1 minus 2 sine squared x will equal to the right side. So in this example, what we did, we used we used a Pythagorean identity, and then we also used a simple tangent equals sine over cosine. We used a reciprocal identity over here, and we also used the double angle, cosine double angle formula, which is cosine squared minus sine squared is equal to 1 minus 2 sine squared, which is equal to the right side. So there we have it. That is how we prove trig equations using trig identities. I hope this helps, and I'll see you in the next video.